The impulse response of continuous time system is given by h of t is equal to del of t minus 1 plus del of t minus 3. The value of step response at a time t is equal to 2 is, we need to find the value of step response at t is equal to 2. Right. Now here we have the system LD, a linear time invariant system. The given input is a step response, step input, and the impulse response is given as h of t is equal to this value. What will be the value of y of t at t is equal to 2? At t is equal to 2, what is the value of y? We know the formula for the relation between output impulse response and input is this relation between output is equal to input convolved with impulse response. When we take Laplace transform, this convolution is converted into multiplication. So u of t is a step input whose Laplace is u of s, that is 1 by s. H of t is the impulse response is given as del of t minus 1, del of t minus 3. We know that impulse response whose Laplace is constant value 1. If this impulse function is shifted by an amount of 1 unity, that is this 1 is multiplied by e power minus s. How much amount is it? It is displayed that much power e power. So here del of t minus 1 whose Laplace is e power minus s. Similarly, it is this delta function shifted by 3, so e power minus 3s. So therefore h of t whose Laplace is h of s value is this. So here y of s is equal to u of s into h of s. For this h of s you substitute this value. U of s is a step function whose Laplace is 1 by s. Now multiply this u of s. Again you take a inverse Laplace transform. This y of s becomes y of t. Again come here. U of t Laplace is 1 by s. When this step function is delayed by an amount of 1, then this 1 by s is multiplied by e power minus s. It is shifted by 1 amount, so e power minus 1 into s. So therefore that is u of t minus 1 Laplace is e power minus s into 1 by s. Otherwise e power minus s into 1 by s whose inverse Laplace is u of t minus 1. So here e power minus s 1 by s whose inverse Laplace is u of t minus 1. Similarly here this is also a inverse step function inverse Laplace transform. It is shifted by 3. So when we take inverse Laplace transform of this function, that is u of t minus 3. Now again we need to plot what is this function. So we know that this is y of t standard step function starting from 0. When this function is shifted by an amount of 1, this is u of t minus 1. Again the second one is u of t minus 3. So again this function is shifted by 3. These two functions are, that is u of t minus 1 plus u of t minus 3. These two functions are getting added. So that is from 1 to 3, that is only one function is available that whose magnitude is 1. So throughout this value is 1. After t is equal to 3, this function magnitude is 1 and this function magnitude is 1. So after 3 the magnitude becomes 2. 1 plus 1 becomes 2. Now the question asked was, what is the value of step response at t is equal to 2? So at the time t is equal to 2, the function value is 1. So at the time t is equal to 2, the function value is 1. So B is the answer. So next question, the unilateral Laplace transform of any function is given by 1 over s square plus s plus 1. The unilateral Laplace transform of this function is multiplied by t. What is a unilateral Laplace transform? Awesome. So we know the famous property called a differentiation property in S domain. So if x of t whose Laplace transform is x of s, if this function x of t is multiplied by a linear function t, then whose Laplace transform is, just differentiate this function with respect to s, then put a minus sign. Now here given one is f of t Laplace is 1 over s square plus s plus 1. So f of t whose Laplace is 1 upon s square plus s plus 1. Now this function is multiplied by t, then according to this property, just differentiate this function with respect to s, put a minus sign in front side. So minus differentiation of this function. So 1 by x differentiation is minus 1 by x square. So based on that, 1 by x is minus 1 by x square. Then inside we have the function, it is in the function of s. So if differentiate that is s square is 2s, s differentiation is 1. So minus minus becomes plus. So 2s plus 1 divided by s square plus s plus 1. So t into f of t Laplace transform is 2s plus 1 divided by s square plus s plus 1. So this is the answer. Consider an LDA system with impulse response h of t is equal to e power minus 5t u of t. If the output of the system is given as y of t is equal to this one, what will be the input x of t? So here in this problem, impulse function is given as e power minus 5t u of t, and output function is given as this e power minus this entire value. What will be the x of t? So the relationship between these three are outputs equal to x of t convolved with h of t. When we take Laplace transform, y of t is y of s. This is convolution in time domain. When we take Laplace transform, it is multiplication in s domain. So x of s into h of s. So we need to calculate what is y of s and h of s. So here h of t is given as e power minus 5t into u of t. So when we take Laplace transform, e power minus at Laplace is 1 upon s plus e. So based on that formula, e power minus 5t is 1 upon s plus e. Again, output is given as e power minus 2t u of t, e power minus 5t u of t. So for this, the Laplace is 1 divided by s plus 2. For this, 1 divided by s plus. So when we take a LCM and simplify, we have the answer 3 over s plus 2 into s plus 5. Again back, so we have calculated h of s, this h of s and y of s. These values are given. So again from this we can write x of s equal to y upon h, y of s divided by h of s. So y of s we have calculated as this one, just to substitute, and h of s is this, that is 1 upon s plus 5. So when we simplify, x is equal to 3 divided by s plus 2. Again when we take Laplace transform, x of s becomes x of t, s domain to time domain. So 3 into, so this, according to this, 1 upon s plus a, whose inverse Laplace is e power minus at. So 1 divided by s plus a, whose inverse is e power minus t, e power minus 2t into u of t. So this is the answer. So this is the answer. The function shown in figure can be represented as, among the 4 equations, we have to select the best one. So the given function is like this. So it is a arbitrary function. So for this function, what is the equation we need to choose? So from the observation, we can say this function having is a combination of one pulse, one square, one pulse, and one linear function, and a step function. So from that knowledge, we will initiate this function. Initially have a pulse with the duration of capital T. So that pulse can be achieved. We know the standard step function starting from 0. When this step function is delayed by an amount t, capital T, so this is u of t minus capital T. When these two functions are subtracted, so u of t minus u of t minus capital T, So here the function value is 1, here the function value is 0, so 1 minus 0 we have the 1. So after t, here the function is 1, 1 minus here also 1, so the function value is 0. So the pulse with the duration of t is achieved u of t minus u of t minus capital T. So from the given choices, we can conclude the choice B and D is not the answer. So the answer may be either A or C. Again come to the given problem. So at t, the function is increases like a ramp function or a linear function. It increases up to time 2t. So we need to write the equation over the period t to 2t. So again we are taking that function separately. So it is a linear function with the coordinate value t comma 0. So this point is t comma 0 and this point is 2t comma 1. So the time value is x-axis value is 2t and y-axis value is 1. So this can be this it is a straight line. We know the well-known formula from the mathematics. A straight line equation x minus x1 divided by x2 minus x1 is equal to y minus y1 by y2 minus y1. So substituting these values, coordinate values, we got the answer x minus t divided by t is equal to y. So the y-axis we have the value y and the x-axis we have the time. X-axis we have the variable as time. So x-axis we have the variable as time. So y is equal to t minus capital T divided by t. So again back to the choices. So in A choice we have t minus capital T divided by t, and in C choice also we have t minus t divided by t. But when we come to this problem, the linear functions start to increase from the time t is equal to capital T. So here from these choices, the linear function is starting to increases from time t. So the answer is this answer. This is not the answer because this is the meaning starting from origin. This is the meaning starting from origin. So the answer is A part. Again, what is the meaning of this one is, so this linear function is gradually increases going like this with a slope of t minus t divided by t, with a slope of this value. So that value is bent. We have to bend at a point 2t. We have to bend at the given graph at a point of 2t. So bend is meaning that we have to reduce the slope. That means that minus sign. We have to bend the slope at 2t. So at 2t. So this is the answer for the given waveform. So next question. Let y of n denote the convolution of h of n and g of n, where h of n is 1 by 1 upon 2 power n into u of n, and g of n is a causal signal. If y value at a time n is equal to 0, the function is 1, y of 1 is equal to 1 by 2. Then what will be the value of function g of 1 equal? So here the given function is a impulse function, impulse response h of n is equal to 1 divided by 2 power n into u of n. So that can be plotted like this: h of n is equal to 1 by 2 4 power n u of n at n is equal to 0, 1 by 2 power 0, anything power 0 your value is 1. At n is equal to 1, 1 by 2. At n is equal to 2, 1 by 4, like this it is going. It is available only in the positive side because of the step function. Now here again this g of n is given as a causal sequence. So causal meaning that the function exists only in the positive cycle. So causal signal is meaning that the function exists only in the positive sequence. So that may be anything. So let I am taking that is a g of 0, 0, g of 1, g of 2, g of 3. So the value may be anything. We do not know the value. Again back. So the given problem y of n denote the convolution bit h of n and g of n. So y of n is equal to convolution bit between g of n and h of n. So when we expand this, we have the formula using convolution formula. We got the formula like this. The second signal is folded. So second signal is folded convolution. Second signal is folded. So this is the second signal. This is the first signal, first sequence, and this is second sequence. The second signal is after changing the variable is n. After changing the variable n to k, then fold the second signal. So the second signal is after changing variable from n to k, the second signal is folded. The second signal is folded. So it is folded like this. So after folding, first signal and the second signal are getting multiplied. After folding, first signal and the second signal is getting multiplied. So now the second signal after folding, it will become like this. We have to multiply. So we have the many cases. When n is equal to 0, what does it mean? There is no shift. Here this n is equal to 0, meaning that this signal is not shifted. The second signal is not shifted. So as it is present. So by that time, what will be the output? What will be the output? So output becomes at n is equal to 0, that is y of 0 is equal to, so this value is g of 0 multiplied by this value. Here we have at 0 time the value is 1. So g of 0 dot, now next one, g of 1, here the function there is no value, so value is 0. So therefore y of 0 is equal to g of 0, y of 0 is equal to g of 0, but a given problem y of 0 is mentioned as 1. So y of 0 is mentioned as 1. So therefore g of 0 is 1. So this value g of 0 we found as this value is 1. Again, when this second signal come to the formula, when n is equal to 0 meaning that no shift, when n is equal to 1 meaning that this signal is shifted by an amount 1. This signal is shifted by an amount 1. So this signal is shifted by an amount 1. Now again this signal is getting multiplied with the first signal. So shifted signal is getting multiplied with first signal. So therefore g of 0 multiplied by, at the time t n is equal to 0, here we have g of 0, the function value is g of 0. Here the function is 1 by 2, g of 0 dot 1 by 2. At n is equal to 1, the function value is g of 1. At n is equal to 1, the function value is 1. Function value is 1. So after that, the function value is 0. So there is no meaning of getting multiplication. So therefore, so again in the given problem, it is given as y of 1 is equal to, again the given problem, it is given as y of 1 is equal to 1 by 2. So y of 1 is equal to 1 by 2. So g of 0, 1 by 2. So we found as g of 0 is equal to 1. G of 0 is equal to 1. And the g of 1, so we need to calculate g of 1. So when we simplify this, we have the answer g of 1 is equal to 0. So here we need to calculate g of 1, that value is 0. So this is answer.